Good morning, students. My name is Assistant Professor of Suvas Vora from Electrical Department at the Sri Swaminarayan Institute of Technology. So, in the previous topic, we can discuss about the what our type induction type relay, what is the functions of induction relay, then after cup type induction relay, and plug setting, current setting, and so on. So now the today's topic is the type of induction relay. So basically the induction relay is work on the two different flux is generated and the torque will be generated. So here the topic is induction type over current relay for the non-directional relay. So first of all, this type of relay works on the induction principle and the torque is generated on the disk when the current in the circuit exceeds the predetermined values. It means that the relay can work only in AC circuit so that they can generate the torque for the fault current in either directions. Here you can see that the figures basic functions is similar for the watt hour meter systems or relays. So here the typical directional induction type over current relay, you can see the figures. So here the two electromagnetics there, the upper electromagnetics which is E type is connected in the series with the lines, this one, and the secondary winding of the cities is connected to the primary winding. Here this one is the secondary windings. Here this one is the secondary windings to connect of the primary winding of the relay. Now the primary winding relay coil is provided with the number of tapping. This one, just 1 minute. Okay, this one is the tapping, and these tapping are connected with the plunger settings. This one is called the plunger settings. Which number of turns on the relay operating coil can vary. They give the desired current settings. Yes, this one is given the desired current settings. Now the secondary winding is energized by the induction from the primary winding and is connected in series with the winding on the lower magnetic. Here the lower magnetic systems. Now the spindles of the disc carries the moving contact with the bridge of the two fixed contact. Here you can see the two fixed contact, and the disc will be rotated through the preset angles. Now we can already set the angles, and this angle can be adjusted by 0 to 360 degrees, so that the relay time can be adjusted by this angle. It means the 0 to 360 degrees, so that the torque on the aluminum disc is set up due to the induction principles, and the restraining torque provided by the spring opposite of this torque. It means this one is the connect of the spring and to restraining torque. It means that कि हम इसको वापस अपनी पोजीशंस में लाने के लिए स्प्रिंग यूज़ करते हैं, So however, it means that if the current in the protected circuit is exceed the preset value and driving torque becomes the generate. Now due to the this driving torque rotate and the moving contact bridge is fixed contact, so that the rotations through the preset angle will be set and the trip circuit operate the circuit breakers. It means here when the fault is occurs at that time, the between the two magnet the flux will be produces, and this flux is more than the restraining torque, and then disc will be rotated and the this contact is connect with the relay and circuit will be opening. So this one is the basic functions of the induction type overcurrent relay for the non-directional systems. Now we can study about the directional system. If I consider that the direction of the overcurrent relay, now the induction type directional overcurrent relay, the constructions is it consists of the one relay element movement on the common case and the directional element and non-directional element. Okay, you can see here this one is the induction type overcurrent directional relay. The directional of the power is reserved. In this case, directional powers is already reserved, and this relay is on the induction type. The constructions is same or similar from the watt hour meters of the induction type relay. Now you can see the constructions of the directional relay. There are the two magnet E type and C type, you can already see in the previous topic, and this potential coil here, the this one is called the potential coil, which is put on the limb of the E shape. Here this one the E limb of the E shaped. Now this coil is energized through the potential transformer from the voltage source. Okay, here the current coil are provided on the outer limb of the C shape here. So these two are connected in series with the energized from the current source through the current transformer CD. It means that the CD. So moving contact are provided on the spindle. In similar way, in the previous topic we can see that the spring, using of the spring. So now you can see the vector diagram coming from the vector diagram. So here the flux phi 1, here the flux phi 1 is produced due to the voltage applied to the voltage coil and which lags of the 90 degree behind the main voltage V. In the flux phi 2 is produced by the current I, which is in the phase with the current. It means that the phi 2 is phase with the current I. Now the phase angle between the vector and the current vector is, it means this angle is phi, which depends on the load power factors. Now what is the equations, so that we know that torque is directly proportional to the phi 1 phi 2 and sine theta. If we can also say that phi 1 is directly proportional to the V and phi 2 is directly proportional to the I. Why V and I? The phi 1, you can see that the phi 1 is produces in the upper coil which is connected with the potentials transformers, and the phi 2 is connected with the lower magnets which is connected from the cities. So, and the theta of the between two angles, you can see that theta is 90 here. You can see the theta is 90 but is minus of phi, this one. So our final equations for the torque is T is directly proportional to the Vi cos phi. So this means that the driving torque is proportional to the power. So we know that the equations of the power Vi cos phi. So this one, the torque is depend on the driving or proportional to the power. So the directions of the torque is depend upon the directions of power flow. When the directions of the flow of the power is normal, the torque depends upon the directions and opposite to the contact. But here the directions of the current is reverse when the fault will be occurs, and this reverse is rotate the disc and the connect with the contact to the trip circuits. So this one is the basic constructions of the induction type directional overcurrent relay. Now the next one is the directional induction type overcurrent. This one is the directional circuits. Now we can study about the overcurrent systems. So here you can see that the directional overcurrent relay consists of the two elements, and the direction element and non-directional element. You can see that the directional element and lower part is called the, this one is called the non-directional element. This one is the combinations of the above two systems. It is essentially that the directional power relay which operates when the power flow in the specific directions, and the voltage coil of this element is connected to the potentials transformer. In the previous topic we can already discuss about the directional overcurrent relay. Now in this system you can see that the trip contact of the directional element are connected in series with the secondary circuit of the overcurrent element. Therefore, in other words, we can say that the directional element must be operated first in order to operate the overcurrent element. You can see that here the contacts. So non-directional element, we know that how it's work. So similarly the similar way to the non-directional element. Now we can learn about the how it's work. If the normal conditions, the power flow in the normal directions in the circuit, therefore the directional power relay does not operate. It means in the, we can see that here in similar way this work is directional relay type and circuit will be not operated. However, when the short circuit occurs, at that time the power flow in the reverse directions and the disc will be rotated, and this will connected with the non-directional overcurrent relay systems, and this disk is element rooted in the moving contact attached to the closed strip circuit and the operate the circuit breakers. Here the current controlled by them is not made by the conditions. Here there are some conditions for the satisfy this all theories. The first one is current flow in the direction such as to operate the directional element. It means that current is must be more than the operating power from the directional element. Current in the reverse directions exceed the preset value, and the excessive current is more than the time setting of the overcurrent elements. So this one is the basic induction type directional overcurrent relay systems. Now the next topic is the connections of the directional overcurrent relay. It means that here in the previous topic we can see that the angles is setting from the 0 to 360 degree. So how it's the connections, we know that the connections is here. There are mainly the three types of connections: 30 degree, 60 degree, and 90 degrees. So this one is the basic connections of the directional overcurrent relay. The connections are depends on the three quantities. So the connections are depends on the three quantities: voltage, current, and the angle. So that these three things will be important in the connections of the directional angles. Now the relay connections are such that the current and voltage applied to the relay during the various fault conditions and which may be arise on the protection system offers by the relay. So when a close up fault occurs, the voltage become low and the directional relay may not develop sufficient torque for the operations. So here the different thing is there. In initial conditions only the 30 degrees will be considered. That if in a after the initial conditions, it means the fault conditions, at that time we can consider the 90 degrees, and then after we can consider the 60 degrees of the relay system. This one is the different connection system of the relay. Now the directional time gradient protection system for the parallel feeder. So we start with the feeders. We can learn about the basic ideas of the feeders. Feeder will be, there are the two types of protections: non-unit type and the unit type system. The non-unit type directional means that they have two time gradient overcurrent protections, and the unit type will be circulating current from the systems. So now the parallel means that the non-directional time graded overcurrent relay system. Here we can learn about the directional time graded system with the parallel. Now consider here the four connections. So the connections will be this: A, B, C, D is the parallel feeders. and the current will be, this one is the power flow, power sources, and this one is the load. So the directions of the power connections will be this. Now every feeders have on values. You can see that from the feeder 1, 8 means A, the pickup value is 1.2 and 960 amperes. The delay time is 0.55 and the directions will be forward. You can see the directions also here. Now in similar way, the B have the 960 ampere similar way, and the C and D. Now the D is open from the 1.1, it means the 880 amperes, and time delay is 0 forward directions. And you can also see here the D is the pickup time is same and the time delay will be 0 and forward. Here you can see that from the power source side the time delay is 0.55 and the load side is 0, because when the fault will be occur, it must be remove the load side current. So here we can learn this the time gradient protections system, because when the fault occurs, now we can consider that the fault will be occur in the A and C, between the A and C, so that first one, the within a 2 seconds this one is will be empty, because the time delay of the is 0. So the starting will be the 800 amperes, that when the fault will be occurs, the current will be infinite, so that the this relay nearest to the C will be operated. Then after the 2 seconds the A will be operated. After 1 second is B will be operated, and then after the 0.5 the D will be operated. You can see that the basic operating time from these systems. This one is called the non-gradient or the non-unit type system, which one is the particular time, but the parallel systems. Now the next one topic is the unit type system. It means that the circulating type connections. You can see that this one is the circulating type, this one is the parallel, this one is the circulating type system. It means this is called the ring main feeder systems. So in the ring main feeder systems is used the power supply system in increase the reliability, so that the power can be fed via other route when the fault is developed in one place. It means that in the parallel circuits the power will be adjusted, but in these systems when the one fault occurs in the any lines, the whole system will be stopped. In the rig main also the directional and non-directional type of the relay used effectively, so that only the faulty sections is isolated and the healthy sections remain in the circuits. So these connections, you can see that S is the source of the system, and the A, B, C and D is connected from the non-directional overcurrent relay are provided on the line coming out from the power stations. The direction type relay are provided on the incoming and outgoing line of the system. Now here you can see that the all connections with the relay, and the relay have some values. This one is operating in similar way that you can see when the fault, you can see here the P is fault and P is fault between B and C, so that the here you can see that 1 2 3, you can see that the radial systems 1 2 3 4 5, it means that A B C D E, and the S system, S means the source, and the fault will be considered in the 1 and 2. At that time the 0.2 seconds to operate the this relay. If this one is failed, then after the 0.5 seconds the second circuit will be operated. If the fail of the second also after the 1 seconds, and the last one is 0.5 seconds to totally open of this system. So this type is called the directional relay or the ring main feeder systems. So now today's topic you can learn about the directional overcurrent relay, non-directional overcurrent relay. What is the angle? It means that how to adjust the angle of the directional overcurrent relay, the parallel feeder circuits from the time gradient, and the ring main systems. So this one is the last topic of the chapter number 2, the current protections of the transformers in a line. If any query about this topic, you can also contact me, and if any questions regard this topic, you can also mail me. My mail ID and the phone number is in your screens. Thank you.